From skyscrapers that seem to appear almost overnight to entire parks created with innovative technology. From airports that float on water to cutting-edge technology reshaping construction itself, China is not waiting for the future. It is building it right now. What you're about to see are massive projects so advanced they make the rest of the world look like it's a century behind. Mini Sky City. Back in 2015, China stunned the world with a project that defied everything we thought we knew about construction. A skyscraper not built in years, not even in months, but in just 19 days. It became a living example of innovation. They called it Mini Sky City, and it demonstrated how modular design can bend the rules of time and traditional building. Soaring 670 feet into the sky, this 57-story giant didn't rise through conventional construction. It was assembled piece by piece. But Mini Sky City was just the beginning. The revolution of building on water and in 3D is already underway. China's offshore airports are masterpieces of maritime engineering, turning open water into critical global infrastructure. These projects require stability and precision at a scale never seen before, challenging the limits of what we can build. The use of 3D printing allows for organic, efficient designs that slash waste and maximize structural integrity. Entire communities are now being envisioned through this technology, blending sustainability with cutting-edge design. By reducing carbon footprints and material waste, China is leading a greener revolution in the construction industry. On-site, the digital and physical worlds are merging. Data-driven management ensures that every detail is perfect. Digital twins and real-time analytics are the new foundation, allowing for precision at an unthinkable scale. It's about building smarter, using every piece of data to ensure longevity and efficiency in our megacities. These projects provide a blueprint for the rest of the world, setting a new standard for global development. China isn't just leading the way, it's defining a new era of human ambition and structural possibility. The future of construction is here, larger, faster, and more intelligent than ever. Thanks for joining us on this journey. China's engineering is pushing the limits of speed and scale, from modular skyscrapers to massive mountain power plants. Take Mini Sky City in Changsha. This 57-story skyscraper was built in just 19 days using modular prefabricated sections. Sections were prefabricated and stacked like massive Lego pieces, allowing for unprecedented efficiency without sacrificing safety. Their next dream? Sky City, a planned 220-story tower that would quadruple the scale of anything built before. High in the mountains at minus 30 degrees stands the Keila Station, the world's largest solar hydro-hybrid power plant. In China, the future isn't just imagined, it's being built at a record-breaking pace. In the heart of the mountains, a monumental feat of engineering has been achieved. This is the Keila Power Station, a project that redefines our relationship with nature. Spanning 170 million square feet, this is the largest hydro-solar hybrid plant in the world. It combines the power of the sun with the strength of water to generate over 1 gigawatt of clean energy. The secret lies in integration. When the sun dips, the hydro station steps in, acting as a giant battery to maintain a stable supply of power to the grid. Keila saves over 600,000 tons of coal annually, proving that even the harshest landscapes can be harnessed for a sustainable future. As we look toward the future, projects like Keila stand as a beacon of hope, where innovation and nature work in perfect harmony. Welcome to the AICT 3D printed park in Shenzhen, the world's first large-scale public space built entirely through intelligent robotic technology. Spanning nearly 60,000 square feet, every detail, from the flowing benches to the intricate flower beds, was crafted by massive robotic arms. These machines use a proprietary concrete mixture, building layer by layer with a level of precision that traditional methods simply can't match. The results are astonishing. The entire park was completed in just 2.5 months, at a fraction of the cost of traditional construction. The flowing landscape creates an architectural style that feels futuristic, almost otherworldly, while remaining deeply functional. By sourcing materials locally and eliminating waste, this project serves as a landmark achievement in sustainable, intelligent construction. The AICT 3D printed park proves that the tools of tomorrow are ready to build the world of today. Join us as we continue to explore the future of architecture. And just like the 3D printed park, the bridge was faster and far cheaper to build than traditional methods, proving once again that China is years ahead in adopting construction technology. The rest of the world is only beginning to imagine the possibilities of these new methods. But what China built next is on a scale that redefines engineering itself. The Hawaii Shikuman Complex relocation, a project that asked, what do you do when a historic landmark stands directly in the path of progress? Most places would make the difficult choice to demolish such a landmark. But in China, the answer was far more ambitious. They decided to save every brick. They decided to move the entire building. Tens of thousands of tons of history shifted to make way for a multi-layered future beneath the surface. City planners wanted to construct a massive underground shopping center, a parking facility, and critical subway connections directly beneath the complex. Rather than sacrificing this century-old treasure, engineers turned to technology. They sought a solution that would preserve the past while enabling the modernization below. The secret weapon was a fleet of over 400 hydraulic walking robots. These omnidirectional machines were designed to lift and literally crawl. A centralized AI control unit acted as the brain, coordinating every single robot. It monitored the weight distribution in real time, making thousands of micro adjustments. Weighing over 7,000 metric tons, this was no simple haul. Every millimeter of movement had to be perfectly synchronized to avoid structural collapse. Each robot could lift 10 tons. Together, they walked the building at a rate of about 10 meters per day, clearing the path for the massive excavation below. With the building safely out of the way, work began on the 3-story subterranean hub, a complex web of subway lines and commercial spaces. Automated drilling robots operated inside the historic structures to reinforce the ground, ensuring the new transit hub wouldn't compromise the heritage above. The Hawaii Shikuman Complex is a rare fusion of Western townhouse styles and traditional Chinese courtyard layouts, representing the soul of Shanghai. Built nearly a century ago, these buildings were saved for the next 100 years. Preserving them is a balancing act of epic proportions. Once the subterranean structures were finalized, the robots were reactivated. The walking giants began their slow return journey to their original foundations. This project is a blueprint for the megacities of the future. It proves that we can maximize our urban space without erasing our precious past. As China continues to push the boundaries of technology, the future of history is being written, one step at a time. The walk to the future has just begun. Join us next time as we explore more engineering marvels. Welcome. Today we explore 2 extraordinary engineering feats, a building that walks and a bridge that touches the clouds. In Shanghai, an 8,270-ton historic building was walked forward by 400 robotic jacks, preserving history while city progress continued below. Every millimeter was controlled by AI, ensuring the century-old structure remained perfectly intact during its journey. After the project was finished, the complex was moved back home, a perfect balance of heritage and innovation. But China's engineering ambitions reach even higher. In the mountains of Guizhou, a new record is being set. The Huajiang Grand Canyon Bridge is set to become the highest on Earth, rising more than 2,000 feet above the river. It's a testament to what we can achieve when we push the boundaries of technology and vision. From walking buildings to bridges in the clouds, we are reaching new heights every day. Thanks for watching. High above the mist-shrouded peaks of Guizhou, a marvel of modern engineering is taking shape. The Huajiang Grand Canyon Bridge isn't just a crossing, it's a testament to human ingenuity. Building something at this altitude posed a challenge unlike any other. Traditional cranes couldn't even reach the site, let alone handle the massive loads required. So, Chinese engineers did what they do best: innovate. Instead of relying on conventional machinery, they designed the largest cable crane system ever built. This massive system became the lifeline of the project. It wasn't just about strength, it was about surgical precision in the clouds. The system was capable of lifting and placing massive trusses, each one weighing more than 21,000 tons. Moving such weight in high-altitude winds requires more than just brute force. To achieve this level of accuracy, engineers turned to cutting-edge technology. They integrated the Internet of Things with China's Beidou satellite navigation system. Beidou provides millimeter-level positioning data in real time. Every movement of the crane, every millimeter of adjustment was tracked by a network of orbiting satellites. This digital oversight ensured that every massive component locked into place flawlessly, even under extreme conditions. But the innovation doesn't stop once the pieces are in place. The bridge itself is alive. It is embedded with a neural network of smart cables and sensors. These smart cables constantly monitor the structure's health, tracking tension, temperature, and vibration. This ensures long-term stability and structural integrity for decades to come. This digital twin allows maintenance crews to predict issues before they even arise. This makes it one of the safest and most technologically advanced structures ever conceived. As the final trusses are secured, the Huajiang Grand Canyon Bridge stands as a symbol of the future. A place where technology and tradition merge to conquer the impossible. I'm your host, witnessing history in the making. The result, a bridge that doesn't just stand as a pathway across a canyon. It stands as proof of what's possible when engineering and technology push beyond their limits. And believe it or not, the next project is just as extraordinary: inflatable construction domes. Construction sites are notorious for two things: deafening noise and choking dust. But in China, engineers came up with a brilliant solution. Entire sites are sealed under massive air-filled structures. These domes trap dust and muffle noise. Inside, advanced systems clean the air before it leaves. This same spirit of innovation is found in the Fosun Foundation Cultural Center in Shanghai. Its moving curtain facade of bronze tubes rotates to harmonize with the city's pulse. From air-sealed sites to moving buildings, engineering is reshaping our future. Shanghai is a city defined by its constant transformation, a metropolis where the past and the future coexist in a breathtaking dance of glass and steel. But among its many landmarks, there is one structure that demands a second look. At first glance, the Fosun Foundation Cultural Center looks like a striking modern theater. But stare a little longer and you'll realize its secret. The building itself moves, with 3 layers of bronze tubes that slowly rotate around the exterior. Inspired by traditional Chinese theaters and weaving, this living sculpture dances with light and shadow throughout the day. This design isn't only about beauty. The moving facade also transforms the building's functionality, revealing or concealing spaces based on the event. It can open views of the river or frame the iconic skyline, making the architecture an interactive participant in the city's life. In Shanghai, the Fosun Foundation proves that even the most solid structures can be fluid. Thanks for watching. It's a rare marriage of art and engineering, a cultural landmark that feels alive, constantly reinventing itself before your eyes. Some buildings look like they came straight out of science fiction. The Anji Culture and Art Center is one of them. Nestled in China's Zhejiang province, a region famous for its bamboo and white tea, this complex is more than just a building. Its most striking feature is the roof, designed to mimic the delicate shape of bamboo leaves, an elegant fusion of nature and modern design. Designed by mad architects, these undulating roofs echo the surrounding hills where the famous Anji white tea is cultivated. Built with sweeping white metal panels, the roof is engineered to appear as though it's floating effortlessly in the air. The gaps between these bamboo leaves aren't just for show. They allow abundant natural light to flood the interior spaces. This design choice blurs the lines between the outdoors and the indoor environment, bringing nature inside. The center features a 17-meter high glass wall, the highest of its kind in China, offering framed panoramic views. It's conceived as a permeable public space, welcoming visitors to explore its courtyards and mountain vistas. Inside, you'll find 6 distinct venues, including a grand theater designed for world-class performances. There's also a massive conference center, ready to host international gatherings and cultural exchanges. From a sports center to youth and art education hubs, this is a comprehensive heart for the community. But this project isn't just about aesthetics and size. Sustainability is at its very core. The structure features a sustainable rainwater recycling system that passively cools the building. By blending beauty with practicality, the center sets a new standard for green engineering in cultural landmarks. Spanning a staggering 1.29 million square feet, the scale of this achievement is difficult to overstate. This monument to creativity and cutting-edge engineering is expected to be completed by the end of this year. It stands as a testament to what happens when we look to nature for architectural inspiration. As it opens its doors, the Anji Culture and Art Center will become a beacon for art and engineering alike. With outdoor venues for performances, it will be a place where culture is experienced in the open air. It serves as a transitional space, connecting the modern city with the timeless beauty of the mountains. Anji has always been known for its natural wonders. Now it has an architectural wonder to match. A true landmark that feels alive, redefining the intersection of human creativity and the environment. Yet, this isn't the only project redefining China's skyline. Beyond the standard skyscrapers, a new vision is taking shape, one that blends sheer height with unprecedented sustainability. In Wuhan, plans are underway for one of the most ambitious skyscraper projects ever imagined, the Phoenix Towers, rising to a breathtaking 3,300 feet. The taller of the two towers would become the second tallest structure on Earth. But for the architects, height is only part of the story. The towers are designed not only as architectural marvels, but as massive energy generators, serving as a blueprint for the future of green urbanism. Their exteriors will be clad in high-efficiency solar panels, capturing the sun's power from every angle to fuel the city below. While inside, advanced systems for wind, thermal, hydrogen fuel cells, and biomass boilers will provide a constant stream of clean energy. Perhaps most incredible is the way these structures invite nature into the clouds. One of the towers will feature a record-breaking sanctuary, the world's highest sky garden, crowning the structure with a touch of nature thousands of feet above the city streets. Built on an artificial island in a lake, the Phoenix Towers are a vision of futuristic architecture that blends sustainability with sheer ambition. It is a design so bold that even the record-breaking developers in Dubai will have to take notice. But China isn't just building taller, it's also building smarter, fundamentally changing how cities interact with the natural world. Enter Sponge City Landscaping, a revolutionary urban planning concept that turns entire cities into living, breathing ecosystems. Instead of lifeless concrete jungles, these cities integrate rain gardens, wetlands, and green roofs into the very fabric of urban design. These landscapes are designed to absorb and filter rainwater, preventing floods while nurturing the local environment. By incorporating wetlands and urban forests, the city acts like a sponge, soaking up excess water and cooling the air naturally. This approach replaces traditional drainage with natural filtration, creating peaceful spaces for residents to enjoy. Green roofs further enhance this effect, reducing energy costs and providing habitat for local wildlife in the heart of the metropolis. Sunken parks serve a dual purpose: beautiful recreational areas during the dry season and temporary reservoirs during heavy storms. These spaces demonstrate that urban infrastructure can be both highly functional and aesthetically stunning. Advanced materials like permeable concrete allow the earth to breathe and drink, mimicking the natural water cycle. The philosophy is simple. We no longer fight against nature, but design our cities to work in harmony with it. From the soaring heights of the Phoenix Towers to the ground-level innovation of sponge cities, the future of urban living is here. As these projects redefine what is possible, they remind us that the most ambitious designs are the ones that preserve our world for generations to come. China's skyline is changing, and with it, the very definition of a sustainable future. For decades, China's cities relied on concrete, gray infrastructure. But today, a revolutionary shift is taking place: the Sponge City, a nature-based approach to urban planning. Instead of fighting rainwater, sponge cities embrace it. By integrating rain gardens, wetlands, and green roofs, these cities absorb, clean, and store water, turning entire metropolises into living ecosystems. From Harbin's Kunli Park to Shanghai's Lingang area, these designs protect districts from flooding while creating vibrant urban sanctuaries. It's a smarter way to build for a resilient future. China is building smarter, one green acre at a time, a legacy of resilience for the cities of tomorrow. Sponge cities, where urban life meets nature. For decades, China's cities relied on concrete, gray infrastructure. But today, a revolutionary shift is taking place: the Sponge City, a nature-based approach to urban planning. Instead of fighting rainwater, sponge cities embrace it. By integrating rain gardens, wetlands, and green roofs, these cities absorb, clean, and store water, turning entire metropolises into living ecosystems. From Harbin's Kunli Park to Shanghai's Lingang area, these designs protect districts from flooding while creating vibrant urban sanctuaries. It's a smarter way to build for a resilient future. China is building smarter, one green acre at a time, a legacy of resilience for the cities of tomorrow. Sponge cities, where urban life meets nature. The Tibetan Plateau is known as the roof of the world, but soon it will be home to a structure that redefines modern engineering. This is the site of the Yanggu Dam, a project that may permanently change how megastructures are built across the globe. Standing 590 feet tall, this massive structure would be impressive enough on its own. But its construction is what's truly incredible. The Yangu Dam will be constructed entirely through 3D printing, just like the printer on your desk, but on an unprecedented scale. Gigantic robotic printers will work around the clock, precisely layering concrete to build the dam's core without manual labor. But it gets even more futuristic. Every machine involved, trucks, bulldozers, and cranes, will be entirely AI operated. These machines work autonomously without a single human driver behind the wheel, ensuring a level of precision and safety never seen before. That means no delays, no human error accidents, and perfect coordination from start to finish 24 hours a day. Because of this automation, the entire dam is expected to be completed in under 2 years. That's a fraction of conventional timelines. If successful, this won't just be one of the most innovative builds in history. It will be a proof of concept for the future. It shows that even the most massive megastructures can be built faster, smarter, and more efficiently through technology. The Yangu Dam is more than just a barrier. It's a window into the future of how we will build our world.